Thank you so much for having me. Really appreciate being here. Britain said, I do love teaching because this is how we help more people. And I think that I particularly like teaching in the integrative space because the medicine is just so wise. And so that makes it easy to have pieces that are meaningful because this medicine is so meaningful. And as we delve into immunity, autoimmunity, immune balance, of course, if I were to say, what system do you want to work with in that area? Everyone would say gut-based health, right? Like that would be obvious to us that we want to think about what type of inflammation is happening in the gut that's starting there but not staying there, that's creating systemic effects on the rest of the body. But then the next question is, okay, what tests should I order? How many tests? How do I look at this area that's so helpful in so many ways? And so I think in general that most of us would really lean towards some stool testing, maybe some food testing. I'm fond of saying it's either a bug or a toxin. But in particular, I want to drill down into lipopolysaccharides today, bacterial endotoxins. And while they're not directly represented per se on a stool test, and so then it's like this next thing, how do I fit it in? I do think the strength of the data is so strong with lipopolysaccharides that it makes sense to think about evaluation in this area when we're working with a patient whose immune system is just hugely out of balance. And so here is a schematic that begins to show what some of these lipopolysaccharides do. And up top, here's the schematic that we're used to, where the gut becomes more leaky. And now what happens is things begin to leak through intact. And that could be byproducts from yeast or byproducts from parasites or even bacteria that do not shed lipopolysaccharides. But lipopolysaccharides are unique in their ability to get into the body, right? If bacteria easily made it into the body, our own healthy microbiome would become a problem because it would drift in consistently, and that would make us septic. This is part of the contraindication, for example, maybe even using some flora in those that are extremely immune compromised, undetectable white counts, because most of the time those strategies are useful to boost immune function. So lipopolysaccharides have all these ways of getting into our system. Sure, they can damage tight junctions and they can come in that way. They can drive leaky gut, but they can even come through cells that are intact. Now, probably that's less likely in our more chronically ill patient. But in addition to that, they move from the portal vein and get dumped right on the liver. So they just get into our system much more easily than those other guys that I mentioned. And so as lipopolysaccharides so easily flux in, they become a big driver of things like metabolic endotoxemia and autoimmunity. So here we see lipopolysaccharides drifting in. They're very good at increasing inflammation, increasing toll-like receptors on white blood cells, making them more upregulated, pushing them in a Th2 response or a Th17 response towards autoimmunity. And so they'll influence these immature dendritic cells and they'll cause them to move more in an aggressive direction. And then this mature dendritic cell moves over to the lymphatics. And in a healthy lymphatic system, this is part of where we regulate the immune system. But even the environmental literature talks about how lymphatics are not as good as doing that as they have been in the past because of environmental toxicity. And so I think we're aware of that. But this is another thing that really influences our white cells, causes them to be more immune reactive. And this is why we see such an escalation of autoimmunity in the past 40 years that genetics just doesn't account for. It is environmental. That's agreed upon, even in standard literature. It's just that in standard of care, there's not very good solutions always to this environmental insult. So these lipopolysaccharides leak in, they cause our white blood cells to become more inflammatory. And over here in lymphatics, I think of the lymphatics as like the home where immune cells should mature appropriately. But if the home is not a good home, if the home is damaged, then we don't get appropriate maturation. And I do want you to file that away because when we are regulating immunity, even doing things like castor oil packs over our lymphatics, or choosing botanicals that help lymphatic drainage, maybe like cleavers or picoriza. These can be thought of as part of how we regulate the immune system. With all of our good diagnostics and being able to drill down into these details, they often lead us back to these more eclectic treatments that we've relied on for years, and the science continues to come forth and really support what's going on. And so from there, this broken home with more environmental toxicity is much more likely to shoot a Th17 cell out into circulation, and it will go on to create more inflammation. If we are lucky, we can figure out ways to move these white blood cells in a direction of T regulatory cells, and these are the ones that put the immune system in balance, Treg. And a hallmark of autoimmunity is that they are down-regulated. If you have rheumatoid arthritis, if you have lupus, if you have Crohn's, if you have autoimmune thyroiditis, you will have less Treg cells. So now, if we know that's a hallmark of autoimmunity, what do we do to increase those? It turns out lipopolysaccharides are even quite damaging here because they have an ability to take whatever Treg cells are there and make them less active. How do we improve the immune system? How do we put it back into balance? We're not wrong. First off, as we build that lining, a thick gut lining, a less permeable gut lining is one of the major things that increases Treg cells. And secondarily to that, getting rid of lipopolysaccharides because they are very unique in their ability to really inflame the immune system. And so when we walk through these immunological theories, like why we have autoimmunity, maybe we didn't delete autoimmune cells like we should, or maybe neutralizing antibodies weren't made. And these are all good descriptions of what begins to happen in a white blood cell. But ultimately, what was the stimulus? Why? What caused that cytokine dysregulation? What prevented that dendritic cell from committing normal death like it should? And when we look through these major mechanisms, lipopolysaccharides really rise to the top in terms of something that is very good at disrupting what's happening for immune function. So when we think about these endotoxins, they're not necessarily specific. They do not act enzymatically, they're heat stable, but they're very oxidizing. They create a lot of superoxides, a lot of peroxides, hypochlorites that are very active, and it's difficult to neutralize them. They stay around for a longer period of time. And I think that this is an important point for two reasons. It really demonstrates the wisdom of functional medicine. So if we're going to treat an autoimmune patient, we would all be thinking about treating the gut, making it less permeable. So getting rid of that bacterial dysbiosis that sheds those lipopolysaccharides. But in addition to that, they create this oxidative burst. And we know oxidative burst can be a reason for onset of autoimmunity, like lupus. It's very well documented in the literature, oxidative burst. So there are a couple ways that we can move T cells in a more inflammatory direction. Lipopolysaccharides is one, but oxidative stress is another. And when I think back to what I learned from Dr. Walter Crinian, one of the pioneers of environmental medicine, he would say, if you want to make an immune cell angry, slather it in toxins. So what does that mean to us in functional medicine? It means we're working on gut permeability, and it means we're working on detox strategies. And that are two of the pillars that we hang our hats on, and they could not be more perfectly related to what happens in autoimmunity. So here's what I was explaining in terms of why they tend to be more problematic for us. So for example, here's bacteria hanging out in the periphery. Here's a parasite hanging out. But lipopolysaccharides have a particular mechanism by which they become endocytosed. They get surrounded by this endosome and they move into the cell. And when that happens, they directly interact with the DNA, increasing things like NF-kappa B, that upstream inflammatory mediator that creates more inflammation. So while all of the bad guys in the gut can do this, lipopolysaccharides are uniquely positioned to be the best at it, getting into our system, wreaking immune havoc, and being a real pivotal point in terms of driving autoimmunity. So when we look at these lipopolysaccharides, they come from gram-negative bacteria that activates a B cell, causes it to make more antibodies. It also increases things like IL-12 and interferon gamma. LPS has been demonstrated to be higher and the immune system more reactive to it in most autoimmune conditions out there. And so much so that if I'm trying to create an autoimmune model in a laboratory, the way they do that is they take their pipette and inject the mouse with lipopolysaccharides. It's a go-to way to create an autoimmune condition in the eye. You inject it there in the kidney, and you will see autoimmunity begin to show up in your animal model. And so we know that it's really important. And if I were in that lab, and I first draw my LPS and I don't get that autoimmune model that I'm looking for, the second thing you do is you add a little mercury. So if I'm in a lab setting and I'm trying to create autoimmunity, lipopolysaccharides, toxicity, the beautiful 1-2 for driving the immune system into overdrive. And so again, it really speaks to what we might do in our medicine. So many of us, if we think about bacterial dysbiosis, one of my favorite antimicrobial botanicals or compounds is berberine. And so berberine is quite effective in terms of killing off some of these gram-negative bugs that are responsible for shedding these lipopolysaccharides. And berberine blocks the ability for LPS to bind and therefore increase toll-like receptors. So here we have our patient that we're getting started with, and maybe they come in and there's some obesity or cardiovascular disease. They're on the metabolic continuum. We see that there's this gut-based component. In addition to those kind of conditions, they also have rheumatoid arthritis, or they have an autoimmune disease. So the wisdom of our botanicals that we can now reach for a Oregon grape or a golden seal that's ethically cultivated or a coptis, all of these plants have berberine in there. Now, we're going to kill off the bugs that are creating dysbiosis. We're going to block the ability for LPS to decrease activity of Treg cells. And in addition to that, we're going to get these cardiometabolic benefits in terms of helping glucose move into the cell out of the periphery, which means it can't do damage. And it also can't continue to feed the bugs in the gut because we're removing that glucose from the periphery. So berberine is an antagonist for LPS, and it blocks LPS from binding to cells, increasing toll-like receptors. So we know that we can get it from a number of places. If we look to traditional Chinese medicine, coptis is a very common botanical that is used that has berberine in it. And why do they choose it? Oh, they choose it because it has this heat clearing, detoxification capacity to it. It gets rid of infectious diarrhea. And if you want to have some good infectious diarrhea, lipopolysaccharides are right there in terms of a causative component. We know that it helps us in terms of berberine can even be helpful, like I mentioned, for diabetes and obesity. Berberine even sensitizes various cancer cells to treatment. So it has all these various mechanisms of action, and so can be quite useful in terms of putting the body back in balance. So here, what we are seeing, a study that looked at lipopolysaccharides and this intestinal injury and concluding that, yes, lipopolysaccharides are one of the major things that increase toll-like receptors that cause those immune cells to be more active and more out of balance. And so even in a world where we are more and more resistant to bacteria, we can reach for things like our berberines. And then we want to think about the fact that T cells are downregulated in autoimmunity. Okay, so how do we get their activity back up? How do we put the immune system back in balance? First, remove the cause. Are there lipopolysaccharides that are drifting in that are affecting immune function? But second, there are a lot of botanicals out there that help us to increase these Treg cells. And you're not too surprised to see curcuminoids from turmeric on the list. You knew that already. You knew it was anti-inflammatory. This is just one more way that it achieves that outcome. And so I think many times with autoimmunity, we've been concerned about using certain botanicals, maybe wondering, well, does it augment immune function? And therefore, is it contraindicated? But an understanding of these Treg cells can really help us to answer that question as well. So, for example, andrographis listed here, and when I think of andrographis, probably the major place that we often find andrographis is in various immune formulas, things that are antiviral, designed to help the immune system. But at the same time, it boosts some immune function. it circles back around to increase Treg function to put the immune system back in balance. And so now we have this way to think about, is this botanical useful? Is it contraindicated? For example, echinacea, good for immune function, but doesn't do a lot for Treg cells, whereas reishi mushrooms, of course, good for our immune system, but do have more of an activity in terms of Treg. So it gives us a discrimination in terms of what therapies we can reach for to help make sure that the immune system is staying in balance. And as you tick through the things on this list in terms of what improves Treg function, you would probably already said, yeah, I was going to think about vitamin D and omega-3 fatty acids for my autoimmune patient because they're anti-inflammatory. And this is just one more mechanism by which that becomes true. So endotoxins, like I mentioned, they are on the outer membrane of the cell wall. The whole bacteria doesn't have to get in. They come from things like E. coli, Salmonella, Shigella, and gram-positive guys will compete with them. So a couple of my favorite gram-positive bacteria, Bifidobacter, Lactobacillus. And so this is part of that reason why we see so much power in our probiotics in terms of not just immune boosting, but putting that immune system back in balance as well. So if we saw a hyperactivity of the immune system to these lipopolysaccharides, that is to say, we see that we're forming IgG antibodies, IgA antibodies, IgM antibodies. We know the immune system is aggressively working to control the lipopolysaccharides, and we know the immune system has become inflamed from these lipopolysaccharides. So we'll reach for things that compete. Bifidobacter, Lactobacillus, not only will they compete with gram-negative bacteria that produce lipopolysaccharides, but our good, healthy bacteria send signals to our genetics to say, hey, don't be so upregulated. So actual downregulation of some of the genes that move us to more away from an innate immune system to more Th2 and Th17. I think that this is fascinating because this is showing, okay, where is there more autoimmunity and allergies? And so what they saw was, okay, Estonia and Finland have more allergies and autoimmunity, and compared to Russia, which had very little. But yet, when we look at the amount of lipopolysaccharides in this schematic, that's represented by this pink bar. And so you see same amount of LPS in Estonia and Finland versus Russia. But the difference being in Russia, what they found was higher levels of Bifidobacter. So again, this so speaks to our functional wisdom. It's not just the bug, but the human being as well. It's not just the bad guy, but our microbiome and how it competes with it. And so what they went on to show is that when there was more Bifidobacter, it would block LPS from having this immune stimulatory effect in the body. So it gives us an idea of why we want to push good, healthy flora in our autoimmune patients, because it's not immune stimulating. It's one of these things that puts the immune system back in balance. And so LPS, it's been shown that it's very toxic to us. Our body knows it's very toxic to us. And so part of understanding when we should dig deeper, when we should be looking at next level testing, I think for most of us out there, when we get started with a patient, we start with some general standard markers, CBC, a chem screen. We want the basics first. We want to make sure you're not in liver failure, you're not in kidney failure. But one of the things that we talk about in boot camps is how we use those markers to go on to decide what next level testing needs to be done. We know you're not dying of kidney failure. Okay, so now what can we do about your autoimmunity? And one that you keep your eye on is pay attention to alkaline phosphatase. So we know that can come from the liver, but if you see a pattern where your other liver enzymes are normal, yet ALK phos is high normal, what else could be going on? It does come from bone. So, of course, making sure there's no big destruction to bone like cancer, or we'll see this in our younger people when they go through a growth spurt, a lot of bone change at that moment. But if it doesn't seem to be from that, we also make alkaline phosphatase in the gut lining. So if you see high ALK phos, what you know is that the local detox mechanism of the gut lining is working. It's trying to kick back at those lipopolysaccharides. It's trying to keep them from getting into the body in the first place, because when they move through the portal vein and get dumped on the liver, goes yikes, and starts to make more cholesterol, triglycerides. This contributes to non-alcoholic fatty liver disease. And then when they move out into circulation, they begin to skew immune function in inappropriate ways. So eyeball that as you're getting started with people, and that's going to help. Okay, is there's some gut dysbiosis. We can fold in some other patterns there to see it's their malabsorptive issue. And if we see that ALK Phos is elevated, it also guides us in terms of treatment. Now think about things like your zinc carnosine or just zinc in general, because it's a cofactor for alkaline phosphatase. So if it's trying to work hard and if it's elevated, we want to make sure that it continues to be able to work hard to keep the lipopolysaccharides out while we're dealing with getting them under control. So zinc drives your ALK Phos, and turns out, okay, so if it drives ALK Phos and keeps lipopolysaccharides from bothering us too much, it decreases diarrhea. Or in some animal models, we see zinc in terms of inflammatory bowel disease or even celiac, etc. So we can use zinc. We knew that already. We're using zinc to build the gut lining, but you're also kicking back at things that are directly toxic to the body. So lipopolysaccharides, they'll bind to our white blood cells, and they're going to cause more activation, more inflammatory cytokines, inappropriate production of nitric oxide, inflammatory prostaglandins, because they're creating all these reactive oxygen species. And so a very interesting study to me was where they took mice, induced this autoimmune model into them, and then said, we're going to knock out a gene that's responsible for holding back our antioxidant response elements. So superoxide dismutase, glutathione peroxidase, our own antioxidant systems that are so powerful. So in this study, but they turn on and off. They knocked out the gene that puts them in the off position. So now in this mouse model, our antioxidant response elements were on all the time. So on autopsy, very little evidence of disease in the keep knockout model, where they knocked out the brakes on those antioxidant response elements, because if you control oxidative stress, you control the progression of autoimmunity. If you control that oxidative burst, you control what's doing damage to those knuckles and rheumatoid arthritis. You control what's doing damage to skin or kidneys. And it's fascinating. If I biopsy the synovial fluid of somebody with rheumatoid arthritis, you find higher levels of LPS there. Also, you find higher levels of antibodies that you see in the serum, IgG antibodies that are attacking food. So if you get an IgG food test back that shows antibodies to casein or wheat, and now you biopsy your rheumatoid arthritis synovial fluid, the same antibodies there too. So this idea that we make antibodies is very validated in the research. And it's fascinating when you drill right down and seeing that root cause, you see the exact things that we would be thinking about looking at for. And so we can measure lipopolysaccharides. And like I mentioned, it's hard when we're getting started with a chronically ill patient. We want the most information, but yet we want to make sure that they can pay some bills at the end of the day, have money to go shop at Whole Foods and do all these other things that we would like to see them be able to do, even have money for the treatment itself. So how do we balance these things? So I do think the most logical way is, where is the weight of the evidence? And so you're not going to ever get me to say anything bad about stool testing. In fact, most of our patients probably need a stool test, but if they have autoimmunity or metabolic endotoxemia, both of those things are highly driven by lipopolysaccharides, and this is a time where I'd consider adding something like that on as well, right? There are times where, okay, we're going to do a stool test, but this patient has extreme bloating and they had a C-section where it all got worse, and we know that was a risk factor for SIBO. So in that situation, we might do a stool test and some SIBO testing so that we can get to the end desire of optimal wellness more quickly. At the same time, we don't always want to be running every single test on every single person. So how do we make that decision? Where is the weight of the evidence? And the evidence is just super strong with lipopolysaccharides. So we can look at other markers that would also contribute to autoimmunity. Of course, we can look at zonulin, tells tight junctions to open. Alessio Fasano did great work in this area, really supporting what we do in functional medicine. He showed that zonulin goes up before the onset of autoimmunity, that the leaky gut, permeable gut, is the environmental trigger that causes these genes to express themselves. And he even was able to show that the arm of the DNA where zonulin is expressed is the same arm where autoimmunity is expressed as well, building this connection right down to our genetics. If we have low diamine oxidase, that tells us that the gut lining is more atrophied because we produce it in the gut lining, but it also means we won't degrade histamine. If you don't degrade histamine, then this is another thing that can cause T cells to continue to be upregulated, really pushing us, continuing us down that autoimmune continuum. I think just really key points to think about your functional foundation. Are they permeable and are they toxic? Both of those things drive the immune system crazy. And then from there, add therapies that are specific in the research. For example, we know androgens can be useful in lupus. We see resveratrol decreases angioedema in scleroderma. There's some good keynotes for different autoimmune conditions throughout these slides, which we're getting a copy of. And so we think about that too. But we want to treat the person. And so this is the wisdom of our medicine, that we're not treating a diagnosis or even a bug, but recognizing that there's a whole person. And so we're going to move in stages. The patients can't do everything at once. That's okay. And that's a bit how you handle, well, when should I and how much testing should I do as well? Figure out if the positives come back that you think that you're going to see, what are the treatments that you want to do for that? And is that going to be already more than most people can handle well? Or is it the sweet spot, like Goldilocks, not too hot, not too cold? And if so, then from there, what we see, then we'll consider some next level testing based on our results, and really spacing things out like this, better for the patient, easier for them to have compliance. So we know that LPS is a marker of leaky gut. It has profound research with things on the cardiometabolic continuum, but it also is one of the big ways that we connect the gut to systemic inflammation. And like I mentioned, if we're trying to do this in a lab, LPS, mercury, boom. Unfortunately, we don't need a syringe to do this in ourselves or most of our patients, allowing the microbiome to get out of balance. And as we age, this is one of the key things that occurs, that we start to have more bacteria that produces LPS and our own microbiome dies off. This is one of the reasons we see more autoimmunity as we age. And another reason we see more autoimmunity as we age is we just get worse. We get worse at making antibodies. So when you're younger, you make a nice clean antibody. It's just going to attack that specific virus. It's just going to attack that specific fungus or whatnot. But as we age, our mechanics aren't as good and our antibodies start to get sloppier, and they are non-specifically bind to, whatever that bug was, but other things in the body as well. And it's another piece of it. And toxicity really drives T cells in a wrong direction as well. So lipopolysaccharides, very damaging. If we want to damage a vessel, like the glycocalyx, the inside of the vessel, lipopolysaccharides are good at that. And we know that we see lots of arterial issues in terms of our autoimmune patients as well. Now we can protect the vessel from that lipopolysaccharide. Things like omega-3 fatty acids are quite good at doing that. That's one of the reasons we utilize them. Again, the second, that they increase things like Treg cells. And finally, that they're decreasing inflammatory prostaglandins too. So this is that connection between bacteria and cardiometabolic disease, leaks in, damages our lipids, activates a macrophage. And so in the cardiometabolic continuum, that activated macrophage is the thing that's going to interact with oxidized LDL and begin to form a plaque. But LPS also upregulates our B cells to make more antibodies, kicking off this T cell response as well. And so this is also why in the community that has more cardiometabolic conditions, they're more at risk for autoimmunity. Or let me say it the other way. If you have an autoimmune condition, you're more at risk for cardiovascular disease because it's the same underlying inflammation that's driving that on both sides of the equation. If you have an autoimmune condition, you're also more at risk for depression because it's that same inflammatory component driving things on both sides of those equations. So when we have more lipopolysaccharides, this will also contribute to obesity. It upregulates something called LOX receptors. And when those turn on, we begin to make more leptin, which tells us to hold on to more fat. So this inflammatory thread begins to move through these different pieces that we see. And yes, LPS, when we treat animals with LPS, it will really significantly accelerate atherosclerosis because of that systemic inflammation. And these chronic infections begin to be what's kicking us off in the direction of more autoimmunity. So low levels, we don't even need that much of it to start causing vascular inflammation. And vascular inflammation, again, is a big component of many autoimmune conditions out there. And so then how do we look at this? Okay, so you could measure LPS directly, but it's probably not the best marker for what we're trying to determine. Because by the time you can measure detectable levels of LPS in the bloodstream, you're really more septic at that point. What we want to know is long before that, what caused the immune system to be irritated. So rather than measure LPS directly, looking at LPS antibodies, IgM, IgA, IgG, because that tells us that the immune system is overreacting to lipopolysaccharides. So we don't want too many lipopolysaccharides, but no matter the amount, we also don't want the immune system overly active to these lipopolysaccharides. When we see high levels of antibodies, it means, yep, there's lots of LPS. The immune system's trying to attack it, creating inflammation, more cytokines, recruiting more white blood cells to the area. And that is what creates symptoms. However, we can see a situation, and more in our Crohn's and irritable bowel disease, autoimmunity, on that side of the continuum, if you see very low levels, LPS, IgM, IgA, and IgG, that is clinically meaningful too. It means that now your immune system is bottomed out and you don't have any protection from lipopolysaccharides. We all have some lipopolysaccharides. So I always think about it like a secretory IgA. When it's up, it means the immune system's fighting, but eventually it will bottom out. And those tend to be more of our chronic patients or people who've been fighting more long-term. So really probably seeing more scleroderma, rheumatoid arthritis in terms of those high antibodies. But once they are low, this is more of our IBD, our Crohn's population, and both are represented in the clinical data. Okay, so in addition to lipopolysaccharides coming from the gut, another really big player is the amount of oxidative stress. And so the oxidative stress could be coming from the gut. It could be coming from toxins in the environment, but it's a big driver in terms of what's happening in the body, what's happening to the immune system. So 8-OHDG goes up when there's damage to the DNA. So usually you're measuring it in the urine because it's a metabolite, and our metabolites are best measured in the urine. And it's a marker that's highly correlated with oxidative stress, with carcinogenesis, with more degenerative disease. And essentially what it's telling you is you don't have enough antioxidant protection for the disease process in your body. And at that level, you're going to get more mutations to the DNA, which is a risk factor for cancer. But that higher 8-OHDG, the representative oxidative stress, is another thing that keeps that immune system upregulated. So how about these patients that we got the stool test and we got the LPS and we treated that, but yet they're still symptomatic, and we're going back and we're repeating our stool test, repeating our LPS. Those things are in normal range. What is it that's driving the immune system? Unfortunately, it's not all leaky gut. It's a big piece of it, but it's not the only thing that keeps those T cells upregulated. 8-OHDG goes up when we're around more tobacco smoke or pollution in general. If you have higher 8-OHDG, you're more at risk for cognitive decline because of this environmental piece. We see urban air pollution, but also indoor air pollution. So 8-OHDG goes up even with something like mold, because when we're at toxic body burden, that's when you're going to see it elevated. Yes, even mercury, arsenic, cadmium, lead. And so it's a really nice screening marker. Again, you don't know why it's elevated per se. It could be all of these toxins. You don't know which one. We were at threshold, and you know you need to treat to pull that down into range using antioxidants, things like sulforaphane or vitamin C, curcuminoids that turn on our own antioxidant response elements and will also increase those Treg cells. But it gives us another piece of the puzzle of why the immune system's gone haywire. So if you run through PubMed, you can see plenty of association with a high 8-OHDG and cancers. And with a cancer, you get more occurrence, more aggression, less improvement, more reoccurrence when 8-OHDG is high, increased risk of cardiovascular disease like as well, but also more autoimmunity. So 8-OHDG is this marker of oxidative damage, and that is implicated in the pathogenesis of autoimmunity. So 8-OHDG we can think of as a mitochondrial marker because DNA damage, DNA in the nucleus, but also DNA in the mitochondria. And so this oxidative stress leading to 8-OHDG formation impairs T cell function, contributes to dysregulation of the immune system, and leads to the development of autoimmune conditions. And so scavenging, cleaning up mitochondrial reactive oxygen species in Treg cells helps them to work better. So this article is about mitochondrial oxidative damage being one of the reasons we lose that T regulatory function. And 8-OHDG is correlated with poor mitochondrial outcomes or an increase in reactive oxygen species in that mitochondria. Oxidative stress will drive autoimmunity, and they go on to say, yeah, this could design novel immunotherapies for diseases with disturbed immune tolerance. And so I always laugh to myself and think we could sit around and wait for the drug, but we're so well armed with how to decrease reactive oxygen species, our green teas and our resveratrols and our curcuminoids. But the question for the patient is always how much and how long? And that's a pretty good question for us too. And that's a hard thing to know from just a history. And so many things I do think, there's lots of things we can get from a history. We can look at white spots on fingernails for zinc deficiency. We can look at scalloping of the tongue for different B vitamin issues. And so there's a lot that we can do for our history. But how do you know if you're at threshold for too many free radicals? And how do you know if DNA is protected or not? So this can really help drive our dosing and how long and how much, because there's a lot of really beautiful antioxidants out there. Like I mentioned, green tea, curcuminoids, resveratrol. Should I use them all? Should I use one? Should I use none? This is a kind of biomarker that can make sure that we're doing this in accordance with what is best for the patient. So if blood sugar issues, we'll have more blood sugar issues with higher 8-OHDG. And then more blood sugar means we're going to feed more bacteria. We're going to get stuck in the loop of keeping the immune system upregulated. And so just a reminder that these things that we do to detox, it's not a singular protocol. It's really more of a lifestyle that we need to coach our patients towards. But we've all had this experience. Hey, patient, I want you to take X antioxidant. No, I don't need it. I put broccoli sprouts on my salads. I get a salad with 5 colors. I drink green tea. So no, I don't think I need more antioxidants. How do we know? This is a biomarker that would tell us where they're at. And it's interesting. It's not even just diet, but how we sleep. If we do not sleep, that in and of itself is an inflammatory response. So it gives us a guide to know, is our patient protected in a lifestyle way that we want them to be? So we can use things like our lactobacillus, like I mentioned, to compete with gram-negative bacteria that's producing LPS. When we're thinking about how to treat LPS, using things that are antimicrobial like berberines, probiotics, CoQ10. Why do I mention CoQ10? Because it protects the heart from the damage that LPS does, and it protects the tissue from some of the damage that LPS does. I really like immunoglobulins as a treatment as well. It walls off lipopolysaccharides and keeps them from drifting into our system. Additionally, immunoglobulins look a lot like zonulin, so they block zonulin from binding, closing tight junctions more immediately. Part of your immunoglobulins you'll absorb, and they will move systemically, but that's okay. Those that you move systemically get broken down into constituent amino acids that protect connective tissue. And if antibodies attacking connective tissue, like I mentioned, like that rat model, we're able to keep antioxidants on all the time, connective tissue stays protected, and there's very little evidence of progression. So immunoglobulins do a lot along this area. And then when we begin to tick through LPS and connections in terms of things like chronic fatigue or activation of various cell response, we see that, again, even something like chronic fatigue, we can trace back to the gut. We can trace back to lipopolysaccharides. Lipopolysaccharides are implicated in terms of fatigue, IBS, brain fog. And here you see they look at serum IgA and IgM markers to LPS because this is the way you're going to evaluate that immune activation to it. We do see lipopolysaccharides being given off by bacteria that are responsible for SIBO. And here, lactobacillus was effective in terms of competing with LPS. And we know, again, that when we look to these conditions over and over, we see good data connecting what's happening in the gut to what's happening systemically as well. So if you want to drive a very inflamed immune system, LPS will drive that Th17 response. Th17 is what's upregulated with rheumatoid arthritis, with scleroderma, COVID. This is our most aggressive kind of post-infectious autoimmune piece that in terms of what branch of the immune system is on overdrive. In this study, they gave probiotics and saw that increased Treg cells and was able to move us back towards an innate immune system. We see increased Th17 with IBD and IBS. Like I mentioned, curcuminoids, they'll increase Treg cells, and they also tap down a Th17 response, further explaining why they're so useful in our autoimmune patients. So what do we do in terms of supporting immunity? Like I mentioned, if we can understand, does this botanical support immune function, but also increase a Treg response? We know we're sitting in a good space. We're not going to push autoimmunity. We're going to modulate the immune system and put it back in balance. So reishi mushrooms was an example that I mentioned before. Resveratrol, curcuminoid. And so as we tick through various autoimmune conditions out there, you'll find the research that associates LPS with various conditions. And so when we look to lupus, for example, we know oxidative burst can cause this, like plastics and dyes and pesticides, but we also see that it's driven by LPS as well. So if we want to train for immune tolerance, that's why we work with our microbiome, because it downregulates what LPS is doing. That's part of the magic of our probiotics. And many of the therapies that we reach for, like butyrate, preferred fuel for the large intestine, part of its mechanism of action is it's decreasing lipopolysaccharides and it's decreasing reactive oxygen species that are associated with it. So again, as we tick through the literature and we look at scleroderma, rheumatoid arthritis, various autoimmune conditions, we see that there's a downregulation of Treg cells, and lipopolysaccharides are one of the big things that do that. You'll get these slides, and within the slides, there are a number of different kind of protocols for various autoimmune conditions out there, but what you'll see is that all of them have a connection back to LPS. So start with the gut, work to detox, and then we can add on some things that are condition specific, but we have to treat the person first. And understanding, is there gut dysbiosis? Is there oxidative stress? That's going to help us to do this.
Welcome to Rupa Health, the best place to order, manage, and track results from over 30 different lab companies in one single place for free. It's going to take you under 2 minutes to sign up, and you can order any functional medicine lab for your client in under 30 seconds. Let me show you how it's done. So here's our beautiful interface. I'm typing in the name of my client, selecting the lab that I want to order for them, and hitting send. From there, Rupa and their amazing team handle the rest. They email the client, collect payment, and even offer an interest-free 3-month payment plan. We've also built the world's largest library of information about chronic health conditions, the lab tests that can help you find the root cause, and the evidence-based interventions that you can use to help people heal from them. It's called the Rupa Health magazine. There, we have in-depth articles about almost any health condition you can imagine. And we give you step-by-step protocols that other clinicians have used to help their clients heal and that are verified by evidence-based sources. You should totally check it out, and it'll transform your practice. And we can't wait to see you. So make sure you sign up today at rupahealth.com.